This video explains how to identify the domain of a function and also use a domain to write a function. A function is a rule that gives a unique output for every input. For example, the rule might be to multiply by 5. The input could be a 3, and after multiplying by 5, the output would then be a 15. Often functions are expressed and graphed as equations, such as 5 times some number, or 5x equals y. Your inputs are your x values, and your y values are your outputs. Now when you graph the equation, your inputs are your x values, and your outputs are your y values. Now it's important to note that not every equation is a function. Only equations that have exactly one output for every input, or one y value for every x value, is a function. Now when trying to decide if this equation represents a function, you could think of it this way. Are there any x values that you could put into this equation that would not produce a real number for your y value? So try some. Let's say you're going to try an easy positive number, like the number 2. Does 2 give you a real number output? Let's see. 2 times 5 is 10. 10 is a real number, so that worked. How about your negative numbers? Negative 3. Negative 3 times 5 produces a negative 15 for the output. That works. How about a 0? Will a 0 give you a real number? 0 for my input gives you 0 for your output, and 0 is a real number. How about a fraction? If you use a fraction for your input, will you get a real number output? Sure. 1/2 times 5 is 5/2, or 2.5. That's a real number. So it appears that for every input that you choose, you're going to get a real number for the output. And then furthermore, you have to consider, is there a number that you could put into this equation that would give you two different outputs? For example, if you evaluate this function at 2, when x equals 2, is it possible to get another value in addition to the 10? And the answer is no. 2 times 5 is 10. It's not any other number. So this equation does represent a function. Now take a look at two sets of points. The first set has 3 points in it. This does not represent an equation, just 3 points that could be plotted on a graph. The question is, does this set of points represent a function? Let's take a look at the inputs. The input of 2 produces an output of 3. The input of 5 produces an output of 1. And an input of 4 gives an output of negative 2. So, does this represent a function? Sure. Every input is different, and every input produces an output. Let's take a look at the second set of points. For the input of 3, an output of 7 is given. For an input of negative 2, an output of 1 is given. And for an input of 3, an output of 2 is given. So here is the problem. You have the number 3 producing a 7, and you have the same input, another 3, or the same 3, producing a different output, the number 2. And while this is still a relation, it's not the special kind of relation we call a function. Now hopefully from the examples you just worked through, you can see that the domain of a function is all the possible inputs or x values of a function. And the function must be defined or give a proper output for each domain value. So no domain value can have more than one output since it is a function. Remember, domain values cannot repeat. Now let's take a look at 3 different problems. The first problem is asking that you find the domain of the graph. So let's begin by listing the points on the graph. The first point takes an input of negative 6 and gives an output of negative 8. So we have negative 6, negative 8. Another point takes an input of negative 2 and gives an output of positive 3. Another point takes an input of 0 and gives an output of negative 4. This point takes an input of 1 and gives an output of 1, and this point takes an input of 3 and gives an output of 5. Now you're being asked about the domain, and the domain is the x values. So our domain is going to be -6, -2, 0, 1, and 3, coming from these x values here. Now the next problem is asking you to find the domain of an equation. The equation is y equals 5x minus 2, and y must be positive. So just looking at the equation, to find the domain, you need to think of x values that produce real numbers for the y values. If you think of a negative number, like -2, -2 times 5 is -10, minus 2 is -12. That works. If you think of a 0, 5 times 0 is 0, minus 2 produces a -2. That works. Think of a positive number, like 5. 5 times 5 is 25, minus 2 gives a 23. That's fine. And maybe pick a couple of fractions. The number 1/5. 1/5 times 5 is 1, and 1 minus 2 is -1. So that produces a real number. At this point, you might think that the domain for this function is all real numbers, since we're getting a real number for every x value we're putting in. However, there is a restriction. The problem said that y must be positive. And if y must be positive, we can see here we've already chosen values where y is not positive. -2 doesn't work, 0 doesn't work, 1/5 doesn't work. So then we have to think about which input values are we going to choose that keep y positive. So the best thing to do here is to take this expression and set it greater than a 0. And that'll tell us when is this expression equal to a positive number. So we'll solve this inequality by adding 2 to both sides. That'll give us a 5x has to be greater than 2, and then we'll divide both sides by 5, which will give us x has to be greater than 2/5. This tells us that if we keep our x values greater than 2/5, we're going to get a positive y value. So our domain in this case is x is greater than 2/5. Now for the last problem, you'll use the domain to identify the function. Look at the equation y equals 2x plus 3 and the equation y equals 3 divided by x. Y equals 2x plus 3 is a linear equation. When graphed, it produces a straight line. You can put any value of x into the equation, and you will get a single value of y out of the equation. So the domain of the first equation is all real numbers. Now think about the second equation. This equation is not linear. You can tell because there's a variable in the denominator. This equation has y equals 3 divided by some number. To figure out what the domain is, think about the input values and the output values they will produce. So, dividing by a negative number, let's choose -3. 3 divided by -3 is -1. That produces a real number. Let's think of a positive number. 3 divided by 3 gives a +1, which is a real number. Even a number that's not a multiple of 3, like 3 divided by 5, still produces a real number, 3/5. However, when we choose 0, 3 divided by 0 is undefined. Remember, we can't divide by 0. So this is not a real number. 0 has to be eliminated from the domain. So the domain of this function is going to be all real numbers with a restriction. All real numbers except 0. Now you know a bit more about domains of functions. See you next time.